Good morning, everyone. We are going to learn how to draw ray diagrams in a concave mirror. So just observe how I am drawing. So you can take any measurements depending upon the book size. So here I have taken the total length is 16 centimeters. So make sure that you draw a diagram onto the right of the page, and use this. Rule lines. So I am drawing a line on one of the rule line. And onto the left hand I am making dotted lines. So the dotted line represents that it is moving up to infinity. It is extended up to infinity. Next is I had to mark 3 points CFP, which are equidistant. So I am marking a point at 0, 8 and 16. If you see, this is C, this is F and this is P. The distance between C and F and P is equal. It is 8 centimeters each. And the distance between C and P is 16 centimeters. Making use of this, I am drawing an arc. Make with the radius C and P. So you can make it with compass, or if you are not having compass, take a strip of paper, mark 3 points which are equidistant, and place pen or pencil at one point and put it on the point C. And this is the other point, and try to draw a line, an arc. And mark the shaded part. Shaded part is onto the right side, and reflecting part is onto the left side. So we have learned the conditions. Object should be onto the left of the mirror, and mirror should be facing the object. Object should be every time on the left side. Okay, fine. Now we'll learn how to draw the ray diagrams when the object is placed at infinity. So when the object is placed at infinity, we know that we don't know where the object is. So it is the light rays reflect from the object from infinity to this mirror. So at the left hand I should mark dotted lines. So make use of these ruled lines. I am drawing a line onto the second line above it. So now afterwards you can draw a straight line which is parallel to the line passing through CFP. The line passing through CFP is called as principal axis. So this light ray from infinity touches this point and reflect back. We have learned that any line parallel to principal axis will pass through the focal point. Don't forget in marking the arrow marks. Next is this. One more line from the object. Left side you make it as dotted line and a straight line up to the mirror. So when a line drawn parallel to principal axis, right ray parallel to principal axis will reflect and passes to the focal point. So I am drawing a line passing through focal point. Don't forget to mark the arrow marks of direction of light ray. So this can be seen by using a mirror. So when you just focus the mirror onto that wall, you see that image is formed inverted. Image is formed in the form of inverted position, and you can see the clear image, and you see that image formed is very, very small, very much smaller. So now what is the position of the image? So in this case, that is object at infinity, image is formed at f. Image is formed at f. Next we shall think of the nature of the image. The nature of image is real and inverted. Next we shall see the size of the image. Size of image when compared to the object is very, very, very small. So we have to write a point as image formed is highly diminished. Next we have to learn few things about these ray diagrams and how to mark the Cartesian. Left and right are the two words that we are going to use here. So what is left and right? We should take the left and right of mirror. When you consider a mirror, the left side of the mirror, the distance which you are measuring on the left side of the mirror is considered as negative, and the distance which you are measuring on the right side of the mirror is considered as positive. This is about distance of object or mirror. Next is above and below. Above and below of what? It is principal axis. Above principal axis and below principal axis. So in this we are going to find here already we have noted down about the distance. Then this we will be learning about height of object or image. Sorry, this is image. Above the principal axis, the height is considered as positive, and below the principal axis, the height is considered as negative. F, small f terms, so it is focal length. Focal length is the distance between focal point and mirror. As it is on the left side of the mirror, the distance, the focal length of concave mirror is considered to be negative, and the value what is given there. Next is object distance. Object is at infinity and it is onto the left side of the mirror, so object distance is considered as negative. Image is formed at f, which is onto the left side of the mirror. The distance is considered from that image to that mirror is considered as negative. Next, height of the object is always considered as positive and it is taken above the principal axis, and image formed will be negative, which is formed below the principal axis. So these are the points that you have to go through.